Hello again, everybody. Welcome to CSEC Math Prep Part 3. All right. We have completed Part 1 and Part 2 of Question 1 and Question 2 of Section 1 so far. Computation number theory. We have done algebra. And for this episode, we are doing geometry and trigonometry. All right. Now, for this one, I'm going to be a little bit different. With geometry and trigonometry, I'm going to show you the common concepts that we'll be covering in the past paper questions that we'll be doing, right? Angles, Pythagoras Theorem, sine ratio, cosine ratio, tangent ratio, and transformation. You're going to recognize that for the 5 questions that we're covering here, these concepts are in all of them, right? So I should have done that for algebra and computation. However, I didn't. So for the subsequent videos, I'll ensure to just show you the common, most popular topics under each of these categories. All right, so let's go. 5 questions from this section now, right? All right, so geometry and trigonometry. First question. In the diagram below, not drawn to scale, GH is a vertical pole standing on a horizontal plane. AJ and K are on the horizontal plane. All right, so you see the diagram there. First, I want to point out that the angle of depression, right, is always an angle formed when looking down from a point. So let's just say you are at point G up there. Your red line would represent your line of sight looking straight ahead. And then the angle formed when you look down to K would be that angle of depression. Now, this question is not asking us to find any angle of depression, but I just want to point that out, right? Because I recognize none of the other question has depression in it for this video. All right, so the angle of elevation is the angle that is formed between your line of sight and your line of sight looking upwards. The question is asking you to put in the angles of elevation to the top of the pole G from J and K, as it said, they're on the horizontal plane. So 27 would be that further angle there. It's a smaller angle to look to G, the further you are from that base point of HG. And then we'd put in a 32 at the other angular elevation there at J. Marks awarded for just putting those 2 angles, right? One of my subscribers, said they had a problem with the sound. Anybody else have any problem with the sound? The idea of the sounds, is to just keep you engaged in the video. In any case, just let me know if you have a problem with the sound so I can get them off if it is too distracting for you, okay? All right, next. Calculate 1 decimal place, right? The length of HJ is our other question. All right. Now, HJ happens to be this line from point H to point J on our diagram. Now, to the 32 that the HJ length is a part of, length 12 is the opposite to the angle, right? And HJ is the adjacent side to the angle. Now, if you're worried about the ratios, they happen to be on the paper at the formula sheet. So you don't have to really remember the formulas, pinpoint, what side go over which side when using the ratios. So here I have a copy of it, and the ratio that has opposite over adjacent is the tan ratio, right? So we're using tan. What we're going to say is tan 32. We always start off like this, writing in this form. The tan of the angle is equal to the respective sides, right? So it's 12, the opposite side, over x, the unknown side, which is the adjacent in this case. All right, there are 2 situations when finding a side, right? The unknown could have been at the top if you're finding the opposite, but in this case, it's at the bottom. Now, when you're finding the unknown and it's at the bottom, what would we switch places, right? We normally use the word cross multiply. I'm going to use switch places. So the x and the tan 32 will just, interchange their positions there. And we're going to have 12 divided by tan 32, and that will give us the value for x. It's really good for you to know, as in to remember how this process works, right? So let's be quick with it. So when the unknown is at the bottom, we'll switch places there. And then the value of x when divided on the calculator is 19.2. If you have a scientific calculator, it's important to get to know how it works. There are some calculators you have to put in the 32 degrees first and then press the button tan to get what the value is. For other calculators, you can just put 12 divided by tan of 32 and you get the answer straight. Really good to see how your calculator functions before you go into the exam. All right, so that is HJ and using the tan ratio. All right, now the other part of the question wants us to find the length JK, right? And what we're going to do for this one is to just ignore this line because the length JK is now a part of the larger triangle. So what we're going to do is use the angle 27 this time around. Now that will not give us the answer for JK. What it will give us is the HK length. And then from there, we can find JK. So let's find what HK is first. So in this case, we have the opposite side over the adjacent side. That is the same tan ratio, right? And tan is unique. It does not have any hypotenuse in it as with the other two ratios. So it's tan 27. And what will it be now? 12 over x. And you already know, right, that when the unknown is at the bottom, what do you do again? Very good. Switch places there. So x is equal to 12 over tan 27. And then on your calculator, please check this out to ensure that it's correct, and also to be, used to using your calculators to find answers relating to the ratios. All right, so it's 23.3, and that is HK. Now, we're going to find now what the length of JK is, given that we have HK. We'll just subtract those results. So it's 19.2 from 23.6. And our answer is 4.4. Based on the calculator, sometimes you may have a situation where you may see differences in the decimal places. I have 4.4 here. In other situations, you might see people with their calculator showing 4.3, 4 point. It's normally a way where if we round to the nearest whole number, we end up with the same answer. Nonetheless, what I was trying to say though is that we don't really have to make a big thing if there's a slight difference, 4.4, so on and so forth. Normally, the examiners ensure that after you round your answers off, most answers would be the same. All right, so it's 4.4 because they wanted the answer to one decimal place. If you notice the other answers, I have them to one decimal place as well. And that's it for our first question. And of course, you can hide the answers from yourself and you can try it on your own. Good. Let's move to our next part of the question. And this is part B of the same year. Now, as I said, transformation is one of those questions that will definitely show its face in question 3, right? And just to point out, there are 4 types of transformation that CSEC focuses on: reflection, rotation, translation, and enlargement. These transformations, they are such that the moment you see them in a question, you can almost tell what they are, right? All right, so I'm going to just use some common words here to describe what these are to avoid some confusion here. So for reflection, it's basically a flip. And we normally need a mirror line when flipping it. It just simply means a line that the shape will be on the other side, the same distance away from the line, right? Sometimes when you're taking pictures and you have something on the left side of your body, you notice that when you look at the picture, it's on the right side, right? There was a flip that happened there. That's a reflection. All right. Rotation is a spin. Translation is just a shift. and an enlargement is a growth. Normally, you see two shapes on the paper. One is large and one is smaller. It's definitely an enlargement. All right, so for this question, it's saying that the figure labeled P, right, undergoes a transformation such that its image Q is Q, sorry, such that its image is Q. Describe the transformation completely. All right, based on the words that I've just shown you, right, the P is shown here and Q is below there. If it's definitely not an enlargement because the shapes are of the same size. It's not a spin, this is a rotation, because this point here on P would be actually, below or above or even on the other side if it was a spin, but they have the same orientation. So it's not a rotation. There hasn't been a flip, the same orientation. It's a shift, which is a translation. And you'll get used to it. So what happened now is that P shift, right, to Q using something called a translation vector. The translation vector normally have two numbers. It just tell you how you move horizontally and vertically to reach point Q. So from P, I'm going to choose one of the points, right? I'm going to choose that point here, the point that's pointing out on P. And I'm going to count going to the right until I'm directly over the same point on Q. So it's 1, 2 across, right? That's the top number in the translation vector. And then 1, 2, 3, 4, 5, 6, 7 down, -7. That's it. So you describe that transformation by saying it's a translation to the vector 2, -7. Even if I'd used another point, so for example, the end point here at the bottom on P, I'm going to count across, right? 1, 2, and then 1, 2, 3, 4, 5, 6, 7. I'll end up in the corresponding point down there, right? And that would be our shift. Shift straight from P down to Q. All right. So that was it for the translation. The other part of the question is asking us, hold on, let me just go and view it, right? So on the graph sheet provided, draw and label the line y equal x. All right, so I didn't mention this before by virtue of the fact that I know everybody here knows what the x-axis and the y-axis is, in case you forget. The line with the numbers labeled going straight across, right, horizontally, that's our x-axis, and the one labeled going straight up is our y-axis. Now they want us to draw the line y equal x on the sheet, and just by how the line is designed in its equation, right, the value of x is the same as y. So you see, let's read the second question before we move the question here. S is the image of P under a reflection in the line y equal x. In other words, they're asking us to reflect P in the line y equal x. Good. So here we go now. If we plot the point 6, 6, right, where it will end up is right there. 6 across on our x-axis and 6 up on our y. So it will be right at the top there. If we plot another point 0, 0, that's the origin. We know that, where the x-axis and the y-axis meet. And yet, if we plot another point -5, -5, we're going to end up right down at the bottom there. So from the origin, we'll go 5 units to the left and 5 units down. Now, for all these 3 points, the x value and the y value, they are the same. That creates our line y equal x. On this line, all the x values and all the y values are the same, thus its name. Now, to get this line, you can plot any 2 points. I just selected 3 just to point out how you can get the line, right? So you could have chosen 5, 5, 2, 2, -1, -1, any one of those combination of pairs. So that's the line y equal x that they ask us to draw, and then they want us to reflect P now in that line y equal x. To reflect in that line y equal x, all we have to do is switch the coordinates. That's something you should note. We're switching the coordinates. So the first one of the points on P is 4, 2. When you switch those coordinates, it's 2, 4, right? That point is right here on the graph paper. 2, 4. Another of the coordinates is 4, 4. When I switch those, there won't be a change. 4, 4 is same place right here on the y equal x line. Another point is 6, 4. When we switch those, we have 4, 6. Its location is right there. And the final point is 7, 2. 7 across and 2 up. When you switch those, it becomes 2, 7. And it couldn't have been on my graph paper here. So I created some lines up there just to, extend. And then when I connect these points using straight lines, we have our shape P reflecting in the y equal x line, giving us that green trapezium there, which is, would label it S. And that would complete our transformation question. If you go through many of the other past papers, you will notice the line y equal x is one of those popular ones that they ask you to reflect in, apart from the x-axis and the y-axis as well. For argument's sake, or some additional information, if you're reflecting, by the way, in the y-axis, this green shape, for example, it would come on the other side of the y-axis. If you're reflecting this shape, the green one, in the x-axis, instead of going up from the x-axis, it would actually come down on the x-axis. In any case, let's just observe what this is and retain what this was in terms of the original question, right? All right. I know when you have the time, you'll go back through, or we will see the concept again in another question. All right. For marks, and let's go. As I said, the concept of angles is one of those things they'll test for in geometry, right? And this concept here, as you're seeing it on the screen, it's called transversal lines, right? It's a pair of, when we have a pair of parallel lines with a line cutting that pair, sorry, we call it a transversal line. In this situation, we have two transversal lines, right? And what the question is asking us to do is to find what the measure of angle X and angle Y is. All right. With the transversal concept, there are some rules or some concepts that arise. They are set in their ways. For example, for angle X is 54 degrees. When we have a pair of parallel lines and a transversal line, the alternating angles are equal. Some people call them Z angles. So let us say we have a line there and we're using it to form a Z, as you see there, right? So look at that, zoops that way, zoops that way, zoops that way. These corner angles here are what we call alternating angles, and they are always equal. So because this one down here is 54, that angle X there, 54 as well. The question asks us to determine what the measure of X is, giving reason, right, for each. So that would be 54 degrees, and we call it alternating angles, right? For Y, the concept, we could use the concept the same way for angle Y. And how it would work is this angle here, right, is 115. Anybody knows what this angle beside it would be? Now, there's a concept called the angle on a straight line, which is 180 degrees. So I'm sure you're not hearing that for the first time. So if you subtract 115 from 180, we would get this angle to be 65, right? And therefore, this angle now, the one that's not there, would be equal to the Y down here, which is also 65. So you could say Y is equal to 65 degrees. And the reason you'd give is angle on a straight line and alternating angles, because those two concepts would help us to get what y is. All right, I'm going to show you another way we could do it. These two angles, they're called co-interior angles. They're at the underside of the transversal line RS. They should add to 180 degrees. So instead of using the angle on a straight line we just did along with the Z angles, we could say that these two angles should add to 180 degrees, right? So if we subtract 115 from 180, then it would just give us y automatically, which is 65. And the concept would call it co-interior angles. So co-interior angles are supplementary, means they add to 180. So when we subtract 115 from 180, we get that y to be 65. So yes, some people would have the 65 over here and then liken it to the y down here the same way. But these two just by themselves are supplementary. So it's 65 degrees. 4 marks. Done. Pointing out, however, additional information. The 115 here, right, that we're seeing in the diagram, it is the same as the angle down here, 115. That concept is called corresponding angles. The reason they're the same is that because for this transversal situation, those angles would be in the same position, right? So you call them corresponding. One more concept on this is not in this question, but additional information. Where we see this 54 degrees here, right? The angle that's opposite to it is also 54 degrees. And the reason for that, the name of that concept is vertically opposite angles are equal. So the 115 here is also equal to the angle over here. It's just as wide, vertically opposite angles as well. All right, so let's move on to another question. That was part A of a question, and then this part now is part B, the transformation question. What is sure is that we are not seeing an enlargement situation here, right? So at least we can eliminate one of the transformation that we know. All right, so what's happening here is that the question says that the diagram below shows triangle LMN and its image L prime, M prime, N prime after undergoing a rotation. Describe fully by stating. So we're going to describe the rotation. It says it's a rotation, luckily. So what happened is when we have a rotation, there's normally a center that the shape spin around, right? Just like having the ceiling fan, the center of the ceiling fan is the center of rotation. That point only turn, it does not move, right? As in shift its position. So these two lines are corresponding points, and they're pointing to M and M prime. And what we'd notice is that it's 0, 0. They are equal distance from the mirror line, from the center there, right? So the center of rotation, that whole shape element is spin around that center, 0, 0. Most of CSEC's rotation surrounds that center there, 0, 0. It does not have to be. There have been times when the rotation was not 0, 0. All right, so the two lines drawn from the corresponding points, you can see that there's an angle being formed here, 90 degree, and it points to the fact that CSEC 180 degrees, 90 degrees are two popular rotation angles, right? This one is 90 degrees. So the angle is a 90-degree rotation, and then the direction. It can be one of two, anti-clockwise or clockwise. So this, in this case, is moving anti-clockwise, right? From there over to the left side there. So it's a rotation, 0, 0 being its center, 90 degrees, and it's going anti-clockwise. 3 marks awarded for mentioning those, right? Easy. All right, the next part of the question says, state two geometric relationships between triangle element and its image. triangle, L prime, M prime, N prime. All right, these are two other geometric relationships, right? For these two triangles, they're exactly the same, right? So similarity and congruent. They're similar and they're congruent. Now, congruent means that they are exactly alike. Exactly alike. Every side, every angle measures the exact same. For similar, there are some conditions. So, but what happens is that all congruent triangles are similar, but not all similar triangles are congruent. However, because these are congruent triangles, it matches both of these relationship description. All right, so or 2 marks. And then the next part of the transformation is asking us to triangle LMN is translated by a vector 1, 2. There are some things that we should pay attention here. All right, we have done translation before, right? Remember, it was 2 minus 7 in our previous question. What's happening here is that they're asking us to go 1 unit to the right and 2 units down this time. But it said determine the coordinates of image of the point L. They really don't want you to translate the whole shape. They just want 1 point. For argument's sake, I'm going to translate the whole shape first, and then I'll show you that point. All right, so I'm going to just add on some more blocks here because the graph paper wasn't enough. A -1 would be there. But I want you to observe that from the origin, the 0, 0 here, it is not the next centimeter they label as 1. They actually skip this one and then label this one. That means you're on both axes. That means the scale is 2 centimeters to 1 unit. Pay attention to the scaling. If you don't pay attention to the scaling, what would probably make the mistake of saying that from 0 to here is 1 and then to here is 2. But no, it's 2 of these units that make 1. So when they say translate the shape going 1 unit to the right, would end up there, and 2 units down would end up right there. But they don't want us to do it with the whole shape. They just want us to do it with 1 point, point L. Point L is this yellow part right here. A tip of that triangle. And when you go 1 unit to the right and 2 units down, it would end up right there. All right. So its original coordinate was 1, 3. 1 unit across here and 3 units up. But after you go 1 unit to the right according to the translation vector and 1, 2 units down, that point now is 2, 1. Right? I'm going to show you another way you could have done this translation. The original point was 1, 3. If we write it in vector form and add it to the translation vector, you should end up with the end result. So what we're doing now is taking 1, 3, we're adding it, writing it in the vector form and adding it to the translation vector. 1 plus 1 is what? 2. This 2. 2 on the x-axis. And when we take 2 from 3, we get what? 1. The y value. 1 right there on our y. So that's 2 ways we could have done the translation. We could just put pen to paper and count across 1 unit and count down 2. Or we could just simply add the point as a vector to the translation itself. And we end up with the end result. Naturally, we'd have to plot this to see where it is on the graph paper. But what they're saying that we should do here is just to determine the coordinates, which is 2, 1. And we're good to go. See, not difficult at all. All right, another year, this is what CSEC had to present to us, right? Obviously, there's no spin happening here. There's no flip happening here. What's happening here is an enlargement. All right, so let's pay attention. Using the dimensions shown in the diagram, calculate the value of K, the scale factor of the enlargement. All right. It's a habit of mine to ignore the reading from the question. So let me just point out that students, when you get the question, always read what's at the top. Sometimes you have some really valuable information there. So the diagram below not drawn to scale shows a triangle OMN and its image O M prime N prime under an enlargement with center O. Remember, every enlargement has a center, and rotation has a center as well of rotation. And the scale factor K. All right, scale factor means just how larger in comparison to the original shape is our enlargement, right? It can be double, in many cases it is, or triple, or it could be quadruple, right? All right, so what we're going to have is the value of K we want to know. All right, the situation that we have here is that if we're looking at the corresponding sides, right, this 8 is corresponding to the 16 on the enlarged triangle, right? And if you observe the numbers, the 8 is multiplied by a certain factor to give us a 16, and that's 2. We could look at it that way. Another way we could come to that conclusion is to divide the 16 by 8. And we recognize that our scale factor there for this enlargement is 2. The second question, the length of OM, right? 1 mark. The length of OM. We can employ something called Pythagoras Theorem. Remember, I have that on the list at the beginning. Pythagoras Theorem states that when you square the two short sides of a right angle triangle, it's equal to the square of the longer side of the triangle, right? The two short sides, 6 and 8. 6 squared plus 8 squared equals c squared. C squared in this case is OM, the length that we're looking for down here. 36 plus 64, that's the square root for those numbers, will give us 100. And then what we do is square root both sides of the equation, and we end up having C as 10. Another easy mark, right? So OM is 10. And then they proceeded to ask, what's the length of OM? That's from the beginning, passing M straight out. Now, if that's 10, right? Remember, the scale factor is 2. So all we have to do is multiply by 2, and we end up with OM being 20 centimeters for another 2 marks. If you're seeing this for the first time, make note of the important things. For example, for enlargement, you need a scale factor, right? For reflection, you need a mirror line. For translation, you need a translation vector, right? All right. Continuing, this question is part B of the question. That's part A and part B. Remember, transformation, trig ratios, most of the times. For question 3 since 2018 here. All right, so let's go for this one. All right, so we're seeing a triangle here. The dimensions are basically shown, and they're asking us to find the length of QS for 2 marks. Now, QS is a part of a triangle, right? Of both triangles, in fact. But if you recognize to the left, that's QPS, that triangle there, it has most of the information that we need, because enough information is not in the triangle to the right for us to find QS. It is a right angle triangle, which means we're going to be using one of the rules, one of the ratios. So that side is the opposite side. QS is what we want to find. And the one that we're given is the hypotenuse, the longest side. Which of the ratios now? Give us the opposite and the hypotenuse in this ratio. Can you make a guess? Sine. Sine of 15, the way we start, is equal to what number goes over which one this time? Opposite over the hypotenuse. Unlike the example we did first, one of the past paper questions, the unknown was at the bottom. Remember when you use that tan ratio? This time the unknown is at the top. What we're going to do now to find the answer is we're going to multiply sine 15 by 12.6. You do not have to put it in the calculator the way you're seeing it here. You can have sine 15 multiplied by 12.6. However, your answer is going to be 3.26, right? And they say you should give your answer to 3 significant figure here. Please, students, pay attention to that for us not to lose any of the marks. So 3.26 is our answer. And that's it. Now, they want us to find the measure of RQS. Now, RQS is that angle right there. R of Q is not what they're asking for. It's just want this part here. And the sides that we're working with now is, we already know that this is 3.26. Remember, we just found it. So it is adjacent this time over the hypotenuse. And by now, we should know the ratio. Adjacent over hypotenuse, we're using the cosine. And if you notice, there are no unknowns this time where we have the sides of the fraction. Because what we're actually looking for is an angle. So we say the cosine of theta, right, is equal to 3.26 over 8.6. Instead of using this symbol that we use for a missing angle, some people would say the cosine of x. It is fine to still say the cosine of x as long as you give us an angle at the end. All right, so you will divide 3.26 by 8.6. Your calculator should be showing you 3.379. And at this point, to find the angle, you're going to look for a button on your calculator that has shift, or you may see second function on it. So you press shift, cosine, then put that number 3.379, and you should end up with 67.7 degrees for that missing angle, RQS. Remember, those who have a calculator that works the opposite way, you'd have to put in 0.379, then press shift, then press second function before you see that 67.7, the 3 significant figures. Good. See? Ratios, no issue whatsoever. All right. Now, I didn't have this on my list originally, but area of triangle, of course, they can ask it with any 3 question, whether it's in section 1 or section 2. For this, you will notice you are able, since you have QS, to use half base times height, which is QS, as it was. But using this formula here is another way. It's half AB sine C, and how it works is, it works for triangles. Most of the time, we're using it for those triangles that are not right angle, as the whole triangle here is QPR. Without this middle line coming here down, we have a triangle that is not a right angle triangle. So you would need these sides here, 12.6 and the 8.4, and the including angle in order to apply this. It's not hard. The including angle and the 2 sides, right? So let's see how it works here. So Q, the angle, so that's that angle, 67.7, we know that. We'll need the other angle as well to use all of Q this time, right? But we all know that angles in a triangle add to 180. So when you add the 15 and the 90 given here, given it's a right angle, and subtract those from 80 to get this side to be 75 degrees, right? So 75 degrees plus 67.7 will give us 142.7. And then you just put in the other numbers just as they are into the formula. Some calculators can work this all at once. You just put in it, make sure you're putting it accurately using the brackets, or you can use multiplication signs here. Remember, those of you who have calculators that work the other way, you have to put in 142.7 sine. Then after that, you multiply by half by 12.6 times 8.4. All doing is putting in the numbers in the respective places. This formula is on the exam paper, so you don't have to worry about remembering it from scratch. And your answer should be 32.1 meters squared. 3. Going good so far. One thing you need to do, go back to the concept, try remember it from without the answers to see where you are in terms of your understanding of the concept. All right, part B, coming down, because the concepts here, they are basically repeating of themselves, right? All right, so in this question, a diagram below not drawn to scale shows the journey of a ship started at port P and sailed 15 kilometers due south to port Q, then a further 20 due west to port R. And the first question is asking us to put in those 20 and 15 kilometers in their respective places. So 15 kilometers due south to Q and 20 kilometers due west to R will look like this. And then 2 marks for doing that. They're asking us now to calculate PR, the shortest distance of a ship from the port where the journey started, right? They're asking us for this then, basically. So what we're going to do now is, what concept we're using, ratios or Pythagoras? We don't have any angle working with, so we're using Pythagoras. Is it the first time we're seeing this? No. So the square of the two short sides is equal to the square of the longer side. Easy. So 400 plus 225, those are the squares for the numbers 20 and 15, will give us 625. And at this point, remember what we do again? We find the square root of both sides, and PR is equal to 25 for 2 marks. Easy. Now calculate the measure of angle QPR, giving your answer to the nearest degree. All right, we're looking for that angle. QPR is the middle length that we're looking for. And what ratio we're using here now? We have the opposite and we have the adjacent. That ratio is 10. So it's 20 over 15. Now when we divide those, what we end up with is 1.33. Now we normally use 3 decimal places when we're finding the ratio, a value for the ratio like that, right? If you round it off too early, it will change the answer by about 2 degrees or so. I'd recommend use 3 decimal places. So the inverse tan of 1.33 is 53 degrees to the nearest degree. Nothing new, nothing hard. Concepts that we have seen before just in this little revision session here. If you check many other papers, you will see the concepts as well. All right. This is one of those transformation questions that I really love. The concepts tested here are amazing, at least how they test the concepts here. All right, so the graph below shows triangle LMN and its image PQR after an enlargement. Obviously, it's an enlargement because one of the shape is small and the other one is large. That's good for us all if the diagram is shown. All right, now they're asking us firstly to locate the center of enlargement, showing our method clearly for 2 marks. The center of enlargement is similar to the concept where you're shining a flashlight on something and then the reflection behind it is larger, the shadow cast on the wall. Now, it would all depend on where the flashlight is, right? And how you find the center of enlargement in this case. You draw straight lines through the corresponding points of the shapes, the image and the object. So these 2 points are corresponding. We draw a straight line going through them. And this point L and point P are corresponding. We draw a straight line through them. Where those lines meet, sorry, at this point here is 1, 5. That is the center of enlargement. Easy concept. It's hard to forget. So we just draw 2 corresponding points, and where those lines meet, that's the center of enlargement. All right. The other question, was, let me just go back and look at it. State the scale factor and coordinates of the center of enlargement. Okay, so we already know what the center of the enlargement is. Its coordinates for it, it's 1, 5. And the scale factor, right? So let's work out the scale factor. And what we use is corresponding points. So this line here, LM, is corresponding to PQ on the larger triangle. So it is 3 times 2, 6, right? The 3 would multiply LM, give us 6 on the PQ on the other triangle. Or, if you remember, we could divide the 6 as the length of PQ by the corresponding side on the image, which is 3. We still end up with our scale factor being 2. Easy. The other one is asking us to find a value for the area of PQR, that's a large triangle, divided by the area of element, the smaller triangle. But you and I know that area is what? Half base times height. So it's half of the 2 unit there is 1, and 1 times 3 is 3. And then half of the 4 unit there for the large triangle is 2, and 2 times 6 is 12. So it's 12 divided by 3. That value is 4. So when you divide the larger by a small triangle, the area a small triangle can hold in a large triangle 4 times, even though the scale factor is 2 based on the corresponding sides. Okay, the other part is asking us to label triangle ABC with coordinates -4, -1, -4, 4, -1, 4, -1, 2. All right, grab our marks there. Don't want to forget that, you know. I want y'all to feel well when you do one of those questions correctly, because garnering marks as we go along is what will make us be in that pass category of the CSEC math exam. All right, so we're plotting these points. The first point is -4, 4. That's right here. We have a yellow mark. And then -1, 4. And then -1, 2. Right? And that's we got now 2 marks there for plot just for just plotting those 3 points. And then describe fully the single transformation with maps element onto ABC. Now, element is that our original triangle on the right here, the smaller one, maps to ABC. Isn't it looking all familiar to something that we have done before? All right, so these are the corresponding points, and they happen to form a right angle degree. That triangle will spin, giving us this one over here, right? And what happens then, and therefore, is that it's a rotation. We have to make note that the transformation is a rotation, and then that the center of rotation is 0, 0. Anything else you remember? That the angle is 90 degrees and the direction is anti-clockwise, right? All too familiar, something that CSEC has tested a number of times. And that's it. All right, we have another transformation question here, and you're going good. What happens is that you are being exposed to a number of ways that CSEC can set this transformation question, right? But the concepts in terms of all 4, rotation, enlargement, translation, and reflection, they are the same. The moment you identify them in a situation, you will know what to do. All right, so let's go. Coming down, what they're asking us here is draw a triangle A prime, B prime, C prime, the image of ABC under an enlargement where the center is O and the scale factor is 2. You and I know. Scale factor is telling us how much larger the other triangle is compared to. Therefore, the coordinates for ABC, right, I have AAC here, but you know it's ABC, my mistake. All right, so it's 1, 2, 4, 2, and 1, 0. When we scale those up by 2, we end up with 2, 4, 8, 4, and 2, 0. And those 3 points are there. And when we connect them, that's our enlargement. So the flashlight was at this point here, 0, 0. Then this small shape would be reflecting that shadow. 3 marks just for that. All right, we're on the ball. All right, now they're asking us now, triangle A prime prime, B prime prime, C prime prime is the image of triangle ABC under a transformation. M. Describe completely transformation M. Now, again, it is also familiar to a question that we have done before. This is not a flip. It's not an enlargement. We have just done that. It's a translation, right? And what we need is a vector. So let's start at B, right? And we count 1, 2, 3, 4 across. 1, 2, 3, 4, 5 down, right? And the triangle will appear there. So it's a translation to the vector 4 minus 5. 4 to the right, minus 5 downwards. For another 3 marks. See? This is our final question in this section. Nothing so far is difficult. All you need to do is make a rap back every now and then and practice one of these without looking at the answers, so the concept can be very clear to you. All right, so the angle of elevation. Naturally, the question above, it's showing all the information that we're seeing there in the triangle to the T. So let's determine the angle of elevation of T from P. Angle of elevation, meaning we're looking up from a point, right? Therefore, T, if we're looking at T from P, then this is the angle of elevation, 40 degrees. It was nothing to calculate, just something to observe in this question here. 1 mark. The length of FP is the next question. And let's observe that 80 is opposite to the 40 and FP is the adjacent side, right? Anybody know what ratio we're working with in this situation? Of course, you are correct. If you had said tan, so tan of 40 is the opposite side over the adjacent side. By now, you will remember that when the unknown is at the bottom, what do? We switch places, right? And therefore we'll have 80 over tan of 40. And some calculators, as I said, can just jump straight ahead to the answer, 95.3. All right, good for 2 marks there. And then finally, the angle of elevation of T from Q. So what we're doing is we're looking for this angle, for this angle right there at Q. Now, if we're looking for the angle at Q, we are going to need all of this length here. All this length, which is the adjacent side, and we're going to use back the 80, which is the opposite side. We're still working on tan, finding an angle this time, right? Note what CSEC is doing here. They ask us to find a side using the ratio. No, they ask us to find an angle using the ratio. They will test for these things, right? So it's opposite 80 over 213. You may ask, where is the 213.3 from? Now, from F to P, the answer that we found first was 95.3. And then going now from P to Q is 118. If we're going to be finding this angle here and we're using a right angle triangle, it is all of FP, FQ that we need. So it is FP plus PQ, right? 95.3 for this part, plus the 118 for that part. That gives the 213.3. When we divide that through, what am I having? There's a repeat, right? Good. So it's tan inverse of 3.75, and our answer is 20.6 degrees. There is, I think there's an instruction from CSEC that says when they don't specify what decimal place to give your answer in, you should just leave it to one decimal place. All right, so 3 marks for that. And as you can see again, the 3 ratios, Pythagoras Theorem, our knowledge of angles, and transformation, all 4 types, reflection, rotation, translation, and enlargement, are what they're testing for in every one of the questions I just did, right? All right, you naturally, I know you're going to find the time, right? And try this question all on your own without looking at the answers. And hereby, we have completed question 3 on our CSEC revision here at CSEC Math Prep. So computational algebra completed now, geometry and trigonometry. Even if you weren't so familiar, by now you have around an understanding of what's coming at that question. Until then, it's CSEC Math Prep. See you next video.